Hi there and welcome back. What we're going to look at just now is we're going to look at some past paper questions for some Hess's law. Okay, so we've got our first one here, which is talking about vinegar and that being a dilute solution of ethanoic acid. To be honest, all you need to look at is the fact you've got an equation and we're having to calculate the enthalpy change for it. Now what we do not have is we do not have about 3 equations, which means we're going to have to make them ourselves from enthalpy of combustion. However, there is one enthalpy of combustion reaction given us for that first one there, which is quite nice. Okay, so they've actually given you the enthalpy of combustion reaction for ethanoic acid. So we're actually going to work through these. Obviously, we're going to try and make this our target equation, and then we're going to try and work through. Okay, so our first one we're going to look at. So obviously, we've got carbon plus hydrogen plus oxygen. Remember, you can't get an equation for oxygen, and then ethanoic acid. So we're going to have 3 equations here, one for the enthalpy of combustion of carbon, one for the enthalpy of combustion of hydrogen, and one for the enthalpy of combustion of ethanoic acid. So we'll start with the carbon. That's going to be a nice wee C plus O2, gives us CO2. That from the data booklet, remember page 10, it's going to be delta H equals minus 394. Then we've got our water, or our hydrogen, sorry, it's H2 plus half O2, and that's going to be 2H2O, that's going to be minus 286. And then this last one here, which is given to us very kindly by the SQA, CH3COOH plus 2 gives us 2CO2 plus 2H2O, and then that delta H is minus 876. Okay, so let's look at our target equation. Let's see what we need to do to these to make them work with the target equation. We've only got 1 carbon here, we've got 2 here, so we're going to have to times that by 2 because it's already the correct side. Same for this one, we've got 1 hydrogen here, we've got 2 here, so times this by 2. We've got CH3COOH, so we've got our ethanoic acid. That is on the wrong side down here compared to the target equation, so we have to reverse that. Okay, so if you're at this point, you're feeling quite confident, then you probably don't have to write out the equations again. You can just look at what we're doing here, but I'll write them out for those of you who want that. I think it's a good idea just to check sometimes, especially if you're in an exam, it's a stressful situation, you don't want to make a silly mistake because you've not entirely got the equations correct, or you've not got the right enthalpy of something. So we'll do this, we'll get 2C plus 2O2, 2CO2, 2H2 plus, and remember we're times that by 2, so that's just going to be O2, gives us 2H2O, and then we're reversing this is 2CO2 plus 2H2O, gives us CH3COOH, not a times, a plus, and then a wee 2O2. Obviously we want to cancel some of these out, so we'll start with our oxygen. We've still got an O2, don't cancel that out because there's only 2 that we can cancel on each side. We've got 2CO2, 2CO2, and 2H2O and 2H2O, which means we've made our target equation of 2C plus 2H2 plus O2 gives us CH3COOH. So we've got our target equation, that's working. That means with these values here, times by 2, times by 2, and reverse. So if I work out this energy change, then it's going to be 2 times 394, which is going to be minus 788. Move that over a wee bit further, a wee bit more space. Then we've got 2 times minus 386, 286, so it's going to be minus 572, and then we've got the reverse of this equation down here, which is going to be plus 874, so So you put all them together in your calculator, you have got minus 486 kilojoules per mole. There we go, so minus 486. So it'll be minus 788 minus 572 plus 874, and that gives you minus 486. Just be careful with your positive and negatives because it's quite easy to make a mistake. Okay, I'll let you see that all in one if you need to pause that at all. Okay, so we have another wee equation to work through. Basically we've got this equation here. This is going to be our target equation. Obviously we're going to have to use this enthalpy of combustion of silicon, which is actually given to us, minus 911, and we know how to work out the enthalpy of combustion of hydrogen, so we also need to use this one here. So we'll write out our three equations to start with. Bearing in mind we'll go back to our target equation, so it's Si plus O2 gives us SiO2, and that would ring a bell from National 5, you know, silicon and oxygen makes silicon dioxide. That's a structured glass, that's quite stable, that's good. Then we've got H2 plus half O2 gives us H2O, and then we'll use this one here, which is SiH4 plus 2O2 gives us SiO2 plus 2H2O. So that's quite nice for us. Let's put some values in just now. This one, enthalpy of combustion for silicon was minus 911. Enthalpy of combustion of hydrogen is minus 286 from the data booklet, and then last but not least we've got this one given to us, 1517. Let's look back at our target equation. Silicon is in the right place and it's got the right number of moles, that's fine. Hydrogen is in the right place, but we need two lots of it to make it the target equation, that's fine. And SiH4 is the wrong way round, because it is on this side in this target equation, but on this side down here, so we'll reverse this. Again, if you're quite happy just to manipulate the numbers at this point, that's fine, but I'll go through just doing these equations again to make sure that you can write our correct target equation. So we've got Si plus O2 gives us SiO2, 2H2 plus, and remember this half O2, you need to just times that by 2, so that's actually just going to be O2 gives us H2O, and then this last one we'll reverse it around, so it's SiO2 plus 2H2O. We need to times that by 2 by the way, and that gives us SiH4 plus 2O2. So let's do cancelling where we can. Obviously we've got 2 O2s here and 2 O2 there, that's fine. 2H2O cancels out, and so does SiO2, to leave your final equation of Si plus 2H2 gives us SiH4. There we go. And that is the target equation. So we've done that correctly. What we're going to do is we're going to use these to work out our numbers. So our delta H, we're keeping that one the same. We're timesing this one by 2 because we had to times that equation by 2, and we're reversing this one. So let's work out the numbers. So delta H is going to be minus 911, and then 286 times 2 is going to be minus 572, and then this is going to be plus 1517 because we flipped that around, so that gives us our final value of plus 54 kilojoules per mole. And that's how you do that one.